Hello guys, and welcome back to my video. So in this video we're going to be taking a look about the block package. So a block is a state management package that's famous and widely used in Flutter to build applications. So we have two elements that we are going to look at. We are going to look at the qubit, and then we are going to look at the block. So a qubit is a class which extends the block base, and it can be used to manage any type of state. So one thing about the qubit is that it exposes functions that we can invoke, and when we invoke those functions, it allows us to change change the state. Okay. So without wasting much of the time, let's get into creating the qubit. Okay. So what you need is you need to go into your pubspec.yaml file. You need to add the block and then the Flutter block, right? And then you have to create two folders, the qubit and then the block. So let's then create our class, which is the counter qubit. We are just going to create the basic counter application, right? Then in the next advanced videos, we are going to be using the block, maybe to get data from the RESTful API, right? Okay, so let's just import the Flutter block. Okay, so to create our counter qubit class, what we do, we just create a class called the qubit, which is going to extend a qubit class, and then with the qubit it takes in a state. So our state in this case is going to be an integer. So it doesn't have to be a primitive data type. When you are building maybe big huge applications, this state might be a class. Okay, and then we then create the constructor for the counter qubit, and then we then provide the initial value of our counter qubit, which is 0, right? So now let's move on to the part where we have to do state changes with the counter qubit. So to do that, we have to create a function called increment. So this function is going to emit a state, which is going to be state plus 1. It's going to emit a new state. So for the qubit, its outputs are going to be states, right? So we are going to just use it to emit a new state. This state, for this new state, we are just going to add plus 1, since we are going to be incrementing it. So the emit function, it emits new state. If we go to this, you can see that updates the state to the provided state. Okay, so then let's go into our main .dat file. What we need to do here is we need to just initialize our qubit. And then what we are just going to do, we are just going to print the state. We're just going to print out the qubit.state. Okay, so this, if we print out, this value is going to be 0, since this is our initial state, right? If you remember, when you initialize, the state of the qubit is 0. And then what we are going to do is if we are going to increment that state, so qubit.increment. So we are just going to invoke this function, the increment function. As you can remember, if we invoke functions, we invoke the functions in a qubit, they are going to result in state changes, right? And then after that, what we are just going to do is we are just going to print out the new state, qubit.state, like this. Okay, and then what we need to do is we just close the qubit. So a qubit is a type of stream. So if you are not familiar with streams, I would advise you to go and learn that asynchronous. Okay, so as you can see now, we got this one, Flutter 0, which is going to be the initial state, and then we then got the next state after we invoke the increment function, which is 1, as you can see from our qubit, right? So since I say that a qubit is a type of stream, that means that if you're familiar with streams, we can listen to the data inside a stream. So that means that with a qubit, it gives us the ability to listen to the state changes, right? Or it gives us the ability to subscribe and monitor the changes, right? So subscription is equal to qubit stream and then dot listen, and then we're just going to print out the state changes. So let's just get rid of these print statements here. So as you can see, we get +1. This is a state change. So if I copy this and then paste it below, and then I refresh, you can see that 1, 2, 3, 4. So as you can see that since the qubit is a type of a stream, it allows us to just listen to the state changes. So these are the state changes that are being printed here. And then one thing about a qubit is that we can observe when a qubit emits a new state, right? So when it emits a new state, that means that a change occurs. From this case, our initial state was 1, and then when we invoked the increment function, that means that it changed from 0 to 1. So when a qubit emits a new state, a change occurs. So with that change that occurs, the good thing about the qubit, it allows us to observe all those changes by overriding a method called the onChange method. So let's go inside our qubit class. So what we just need to do is we just need to override the onChange method. Okay, let's override the onChange method. This is a change of type integer, then provide the change and then after this we're just going to print out the change. Okay, so if we go into our main function, what we can do is we can say counter qubit, and then we can increment it, and then we can then close the stream after we are done. So if you can see, and you can see that we get the change. So the change consists of the current state and then the next state, which is 1. Okay, so what happens is that a change occurs just before the state of the qubit is updated, right? For example, if it was 0 before it's about to get 1, that's when the state of the qubit is updated. Okay, and it consists of the current state and also the next state, right? And then the other thing, one thing about the block library, it allows us to monitor all the changes from our qubits in one place. So we can monitor all the qubits, all the changes in our qubits in one place. So to do that, I will simply create a class here inside the lib. I'll create a folder called the block observer. So inside this block observer, what I'm just going to do is I'm just going to say counter block observer dot dat, okay, like this. So and then the class counter block observer. it's going to extend the block observer like this. Okay, so inside this class we just need to override the onChange method. And then we just, in the onChange show values, we just have to provide the block and then the onChange, and then we can just print out the block.run type, and then we can also print out the change, right? Alright, so what are we doing here? So as you can see from this class, this counter block observer, it extends the block observer, so an interface for observing the behavior of block instances. So as you can remember, or if I didn't specify, the qubit on itself, the qubit extends the block base class, right? It extends the block base class, and also the block that we are going to be looking next, it extends the block base class. So what this does is that if we go back to our counter block observer, as you can see, we now have the block observer. The block observer, what it's going to do is it's going to observe all the block instances. In this case, since the counter qubit extends the block base, it's going to be observed by the block observer. Any change that is going to occur in the counter qubit is going to be observed by the block observer. If we have another qubit that will create, it's going also to be observed by the block observer, right? So let's go into our main function, and then let's just do this block.observer is equal to counter block observer, right? Like this. So if I just refresh this application, you can see now we have the counter, we have this value called the counter qubit change. As you can see, it's giving us the current state and then the next state. So this as you can see, it's giving us counter qubit, which is an instance. It's coming from the counter block, which this one, the counter block observer, it's coming from the counter block observer. And then we have the internal one that we created inside our counter qubit, this one, which is being displayed here, the change here. So what happens is that the internal onChange, this onChange here inside the counter qubit is invoked first, is called first, and then once this is called, it then notifies the block observer of the changes inside the counter qubit. I hope this makes sense, right? So now what we are going to do is the next part we are going to do is we are going to look at another element of the block package, right, which is the block. So unlike the qubit, which uses functions to trigger state changes, the block uses events to trigger state changes. As you can see, we have this event class, right? It uses events to trigger state changes, right? So let's go back and then let's go inside our block, and then we are just going to say counter block dot that. So unlike the qubit, with the block, what we need to do, the first thing that we need to create a class called the counter event. We create a class called the counter event. The next thing is we need to create the event for incrementing the counter, which is counter increment pressed, which is going to extend the counter event. And then what we just do, we're just going to create a counter block, which then extends the block. And then the block, what the block does is that it takes in the event, the counter event, and then it then takes in a state. Okay, so let's just import this block. So it takes in an event, which is the counter event, and then the state. In this case, it's a primitive data type, which is an integer, but it can be a class. And then what we need to do is we just need to create a constructor for the counter block, and then we need to set the initial value of the state. In this case, the initial value of the state is going to be 0, right, like this. Okay, so that's how we create the block. Okay, so now we need to add events, right? We need to add events. So to add events, what we need to do is we just use the on method, which is going to take in the counter increment pressed event. And then so what this takes in, it takes in an event and then an emit function. Since if an event is triggered, it's going to emit a new state, right? So to make it easy for you guys to understand, right? So it's going to emit a state +1, okay, like this. All right, so when this function is triggered, it's going to increase the state. Okay, so like we did with the qubit, let's go inside our main, and then let's go inside the final. Let's install the block, which is going to be counter block. Okay, like this. And then we are going to just print out the initial state. This is a block.state. And then we just need to add the event. So to add the event, we use the .add function. Our event, if you can still remember, was counter increment pressed. Okay, and then we need to print out the state afterwards, the new state. Sorry, it's block.state. And then we just have to close. We just have to close the block once we are done, like this. Okay. So if I okay, so the reason why it's not is because after this it's going to close the block suddenly. So to avoid that, what we need to do is we need to just introduce a delay. Alright, like this. And then okay, as you can see, we have the initial state, which is 0, and then after we add in the counter increment pressed, our state increased from 0 to 1. Okay, so just like the qubit, the block is also of type stream. The entire block package is based on the stream. So if you don't understand streams, I would strongly advise that you go and try to learn streams. So what we are just going to do is let's get rid of this new statement, and then we are going to just subscribe subscription, which is go to block.stream, and then we are just going to listen, and then let's print out we listen, and then let's just print out. Okay, so if you can see Flutter 1, okay, we are just going to listen to state changes. So if I just copy this and then copy this and then paste it below, yeah, we can see that we are printing all the state changes. Since it's of a type of stream, it allows us to just listen to all the state changes, right? So the other thing about the block is we can also observe state changes inside a block, right? We can also observe state changes inside a block, right? So to do that, what we need to just do is we need to override the onChange method like we did inside the qubit. So as you can see, the block is almost similar to the qubit, and there are just a few differences that you see in the next steps, right? Then we can just print out just print out the change. Okay, so let's go into our main.dat file. Let's just get rid of this everything here. So let's just initialize the counter block class, counter block. Then we just need to add our event, which is going to be counter increment pressed, and then after that words we just need to close. Okay, so once we just, as you can see, we get the state changes, we get the change from the block package. As you can see that the change, it gives us the current change and then the next change, right? So one key difference between the block and the qubit is that the block is event driven. That means that the block uses events to trigger state changes, right? So just because the block is event driven, we can also able to capture information about what triggers the state change. We are able to capture events that trigger the state changes. So we do this by overriding another method called the onTransition, right? So the onTransition is just going to give us the events that triggers the state change. Okay, so let's do it. It's going to take in a transition, and then it's going to be a counter event, and then it's going to take in the state. Okay, so we have the onTransition function. It's going to take in the transition, which is going to take in the event and then the state. Okay, right. So what the onTransition, when the onTransition is invoked, what it does is the onTransition is invoked before the onChange, and it contains the events that triggered the state change from the current state to the next state, right? So if I just rename this, you can see that we have the transition, which gives us the current state, and then we get the instance of the event that triggered the state change, which is the counter increment pressed, and then we get the next state, right? So also, just like the qubit, the block observer, we can allow us to, the block can allow us to observe state changes using the block observer class. We can monitor the state changes, and then we can also monitor the transitions, right? So if we go inside our counter block observer, below we can just say void. We need to overwrite the on transition. Super dot on transition. Okay, so now if we go to our main file, what we can do is you can just say block.observer is equal to counter block observer, like this. Yeah, and then if we just refresh our application, we can see that we are getting the counter block transition. We're getting it from the counter block transition, and then this counter block transition is coming from our block observer class, and then we're getting the transition, which is the internal one, the counter block change, and then the change, which is internal one. So as you can see, the on transition that is in the on transition inside this block is triggered first, which then notifies the block observer of the changes in the events, which then triggers this one. So it's always local before global, right? So that's was it about the block and then the qubit. So you might be wondering, we have the block and then we have the qubit. So which one do you use when you are building your application? So when you are dealing with small applications, it will be advisable to be using the qubit because of its simplicity. And then if you are building maybe large applications, it will be advisable to be using the block. And also the block has the advantages that it allows us for traceability. As you can see, we can trace the event, we can trace the events, we can even trace the states, right? So that was it, guys, for the block state management library. So in the next videos, we're going to be looking about the UI part, accessing block and qubit inside our user interface. Thanks for watching, guys. Cheers.